implicit differentiation. So before we do this question, let me remind you what is this implicit differentiation. When you're given something like x squared plus y squared is equals to like 2 there, we say that the subject or the formula for this equation is not y. So it means that we need to find the differentiation of each of these terms. But where we have y, we have also to add dy and dx. So in this case here, differentiation of x squared is what? 2x.
2x, yeah.
Plus differentiation of y is still 2y, but because you are taking differentiation of y, we need to write what? Dy dx, and differentiation of 2 is 0 there. Then we need to make dy and dx to be the subject of the formula. So we have our 2y dy dx is equals to minus 2x. We divide by 2y, divided by 2y. We cancel there. Then you get our equation as dy and dx is equals to minus x over y. So that becomes the answer. So the implicit differentiation means that anytime we find y, we have to do what? We have to write dy and dx there. Yeah. Okay, that's okay. So let's do the one that is on the board. Now, what is the differentiation of this one? We take this one together. This I get 2 over 3. Then x, we have 2 over 3 minus 1. Then positive 2 over 5. Y. Then 2 over 5. We also minus what? Minus 1. But because you are taking the differentiation of y, we need to do what? Right, dx there. And differentiation of 1 is 0. Then this one is going to have 2 over 3 x. 2 over 3 minus 1 is 1 out of
minus 3 over 5.
Minus. Then positive 2 over 5 y.
Which, isn't it minus 3 over minus 3 over because it's 2 over 5, not 2 over 3.
Like this is 2 over 3 minus 3 out of 3. What is
2 over 5 is the power, x to the power of 2 over 5.
This one?
Yeah.
It was 2 over 5.
Yeah.
Oh, it was not 2 over 3.
No.
Okay. Okay. So if it was, so they were the same powers.
Mm-hmm.
Oh. Then we need to write this one here. 2 over 5 is 2 out of 5. Then we need to do it again. So we have to take 2 out of 5, x 2 out of 5 minus 1, then positive 2 out of 5, y 2 out of 5 minus 1 is equals to, no, we write dy and dx is equals to 0 because the differentiation of a constant is 0. Then we have 2 out of 5 x, and what you get 3 out of what? 5 minus positive 2 out of 5 y minus 3 out of 5 is equal dy dx is equal to 0. Then we make the dy and dx to be the subject of the formula. So we have 2 out of 5 y minus 3 out of 5 dy and dx is equals to minus 2 out of 5 x to power for minus 3 out of 5. Then this case here we divide by 2 out of 5 y to power minus 3 out of 5 divided by 2 out of 5 y to the power minus 3 out of 5. So this one comes out. Then you get our answer as our dy dx is equals to, what is 2 out of 5 divided by 2 out of 5? Is minus 1, eh? It's minus 2 out of 5 divided by minus 2 out of 5. You get minus 1. So you get minus 1, then you have x minus 3 out of 5 over y minus 3 out of 5. But sometimes we don't need to leave the answers in with a negative indices. Eh? So we can switch and become what? Y to the power 3 over 5 divided by x 3 out of 5. And then you put the minus there. So we can get away with the negative exponents like that. Do you see it?
Yeah.
So this one here, we need to also apply the implicit differentiation. So you need first of all to cross multiply. Huh? When you cross multiply, what do you get? X is equals to 10y, like that. We can also put them in the same side. And I can still do it like that. So what is the differentiation of x?
Just 1. Right?
1, yeah. What differentiation of 10y? Is also 10. But anytime we take the differentiation of y, we have to write dy dx. Then you divide by 10 here, divide by 10. Cancel there. We have dy dx is equal to 1 out of 10. Like that. So that becomes our answer for that. That was very simple. For this, we need to use still implicit differentiation, but here there's a power here. This power tells us that we need to take logs, both sides. And remember, this one is just a constant. This is just a number. E to the power 2 is a number. It's not it's not like this x here, okay? If it was like e to the power x or power something, this would be a function. But this one here just a number, like 2, like 4, because when you put this one in your calculator, you get a number. So this one just like it can be like 5x, okay? Like 5x here. So you know how to differentiate that part.
Yeah.
So this just e to the power 2 there. So now we need to take logs on both sides. We have ln of x squared e squared there plus y ln of 2 is equal to ln of 5, like that. Now what is the ln of, okay. Now in this case here, we can now take differentiation.
Okay.
We see that when you have this power here, this we can also take at the back here, okay? So it's going to be 2 ln of x, then we have ex. So this ex is just a number, so you can even write it at the back here. You can write 2 e to the power 2 ln of x positive y ln of 2 is equal to ln of 5. Now, also this one here, ln of 5 is just a number. When you put in calculator, you get just a number. So differentiation of a constant is just 0. Now this one here, there's so in this case, you're going to have, what is differentiation of this one here? Differentiation of ln.
Is it like 1 over x?
1 over x. And this one here, this one are not, this is just a number. So just number like 5 or 4. So this answer will be 2 e to the power squared over x. Then positive. Differentiation of y is just 1. Then you have, but anytime we take differentiation of what? Of of y, we have to write dy dx. So you need to write dy dx. Then ln of 2 there, ln of 2. Because if it was like 5x, then differentiation would be 5. So that's why you have to write this one here, ln of 2. But this one here is 0. The differentiation of a constant is 0 there. Then you have to take the other side here. We have our dy dx ln of 2 is equals to minus 2e squared over x. Then divided by ln of 2 divided by ln of 2 there. So we cancel here. We have our dy dx is equals to minus 2e squared over x ln of 2 there. So that becomes our answer. We're going to put this